Okay, we've established that near x equals negative 3/4, the negative 8x minus 6 factor is going to be 0, and the product of all the other factors is going to be negative. So that if x is slightly greater than negative 3/4, that's going to make this term here positive. All the other terms being negative, that's going to make the value of y negative. So that as the graph passes through negative 3/4 0 here, it's going to pass through in the negative direction. And if x is slightly less than negative 3/4, that's going to make this term negative, and since all the other terms multiply out to be negative, that's going to make the value of y positive. So y is going to go, the graph is going to go through the point negative 3/4 0 from positive to negative. So graph is going to go through negative 3/4 0 positive to negative. Now we want to look at what happens at and near x equals negative 1. X equals negative 1, as we've seen, being the value that makes 8x plus 8 0, the other value that makes the numerator 0. So if x equals negative 1, of course, y equals 0, but all the other factors are positive. Okay, you can plug negative 1 in here, here, or here, and you're going to get a positive. In these cases, the negative coefficient times the negative 1 is going to give you a positive. You're going to have plus 8 minus 6 here, plus 6 minus 3 here, both positive. And of course, negative 1 plus 6 is positive. This means that if x is slightly greater than negative 1, since that makes 8x plus 8 a little bit greater than 0, this entire product here, or the entire calculation, is going to be done with positive numbers. These numbers are going to stay positive. Changing x by a little bit isn't going to change the fact that these three expressions are positive. And since this one's positive, that means y is going to be positive. So if x is a little bigger than negative 1, y is going to be positive. That means you're going to go from 0 up into positive numbers. Your graph is going to be going through the point negative 1, 0, and it's going to be going from negative to positive. Also, if x is slightly less than negative 1, I got just dots, that implies that y is less than 0. The reason being that that's going to make this term negative, and then you're going to have a negative times 3 positives, and it's going to give you a negative. So the graph through negative 1, 0 is negative to positive as we go from left to right. Okay, so what's that going to do up here in this picture? Well, that is going to also be the case here. We don't know exactly what the slope will be, but we know the graph is going to come through here on the way up, and it's going to come through here on the way down, which means it's not going to get to go far. It's going to come up here, turn around, and come back down. Now, if we enlarge the interval from negative 1 to negative 3/4, we can see a little more clearly what's going on. We see that the graph of the function goes through this point, going from negative to positive, through this point going from positive to negative. So the graph is going to have this sort of shape. Now that's between negative 1 and negative 3/4. If we draw the same thing up here on the slightly smaller scale, it's going to happen again, but that rounding will occur on a very small part, or a fairly small part, of the x-axis. But that's what the graph is going to look like in the neighborhood of -1 and -3/4. Basically what the graph is going to look like. There are details. We don't know if this is maybe a little lopsided this way or this way, but we're pretty sure it's a smooth curve one way or the other. Now, next thing we want to look at is what happens when the denominator's 0. And that, as we've seen, occurs when x is equal to -1/2, and also, -1/2, and also when x equals -6.